Okay, now we're going to talk about S12C, Part 1, tangent lines. Okay, so first of all, we start off with slope. You know slope is rise over run, and slope is also the derivative. So you may have learned in Algebra 1 that slope is equal to the difference of the y values divided by the difference of the x values. Okay, if I multiplied x2 minus x1 on both sides, we get something like this. Okay, and if I added y1 on both sides, we would get something like this. Okay, and we're going to be using this to help us find the equation of tangent lines. Okay, so a tangent line is a line that hits the curve at one spot, and it's just a straight line. Okay, so we need the coordinates of a point. So if x is the a value, then this is the y value for that point. And then we also need a slope. To get a straight line equation, we need a point and a slope. Okay, so here's my slope, which is the derivative, x minus the x value and the y value. You might want to hit pause and think about this for a second. So this gives us the equation of a tangent line, which is a straight line. As I said, you might want to pause and think about this for a minute. Okay, so here's the first example that we're going to do. Find the equation of the tangent line to f of x equals x squared plus 1 at the point where x equals 1. Okay, so what are they saying here? We're trying to find a line, right? So first off, we're going to try to find the y value when x is 1. Right, so we take our original function, f of x equals x squared plus 1, and I'm going to plug in, since we're trying to figure out when x is 1, I'm going to plug in 1 for x. So I get 1 squared plus 1. And then my y value is going to be 2. Okay, so the point of the contact of this curve is this. So let's just think about this for a second. This is a parabola plus 1. So so we've got this a parabola here. Okay, and when x is 1, y is 2. Okay, so that's the bottom. Sorry, I messed up that, but we've got this point right there, and we're trying to figure out the slope of this line right here. Okay, let's draw this a little better. Okay, and we want to figure out this slope. Okay, so we've got this point, 1, 2, and now we need to figure out the slope. So I take the derivative of this, and the power comes to the front and becomes the coefficient. We got 2x, and then the derivative of a constant number is simply 0, so we end up with the derivative formula is only 2x. Okay, so now I need to plug in 1 in place for x, and if I plug in 1 in place for x, we're going to get the slope is equal to 2. Okay, now using our formula, this equation here, for the equation of a line, I'm going to replace our slope here with 2, and I'm going to replace this x value here with 1, and this y value here with 2. So So we're going to replace this x value here with 1 and the y value here with 2. And we said our slope is 2, right? Okay, so now we can do distributive property with 2. I get y minus 2 equals 2x minus 2. And then the last thing is we subtract 2 on both sides, and we end up with y equals 2x. And that is the equation of the tangent line. Okay, and remember, a tangent line is a straight line that has the slope that it touches the the curve here. Okay, now we're going to do a trickier um, problem that requires the use of the calculator. Okay, and before we get started, all of the steps for what we're about to do is on the, you can download these instructions and they are in Canvas for you. Okay, so this is S12C, finding the equation of tangent, calculator instructions. Okay, so let's do the question that's on the S12C calculator instructions. It says f of x equals this function, negative 0.02 x squared plus 3.4x. Use technology to graph this. Okay, so the first thing I'm going to do is I'm going to get my calculator out. Okay, and so I'm going to hit y equals, and then I'm going to type in negative, the negative down here, right? 0.02 x squared plus 3.4x. Okay, and then I'm going to hit enter, and if I press graph, then I get something that looks like this. And you know this is supposed to be a parabola, not a straight line, so we need to fix the window. Okay, so so what am I going to do? I'm going to press window, and I need to change the x max and y max here. So I'm going to change this x max to 160, and I'm going to change the y max to 160, and then I'm going to press graph. And now we're going to get our parabola here. Notice it's upside down, and that's because of this negative. That's going to make the parabola upside down. Okay, so now I want you to find the derivative. So if I use our rules of derivatives, we know this 2 gets multiplied by the coefficient here. This coefficient 2 gets multiplied by this part here, so we end up with negative 0.04x, and the derivative of 3.4x is, oops, that's a mistake. It should be 3.4. Okay, so here is our derivative of this function. That should not be there. Okay, next, find the slope when x equals 50. Okay, so I'm going to show you calculator steps to do this. So the first thing I'm going to do is I'm going to press second trace. So second trace, and then to get the derivative, which is the slope, I'm going to hit the number 6, either that or arrow down to number 6 and hit enter. And now I get the screen here. What I'm going to do is I'm going to type in 50 because I want to know the slope when x is 50, right? So I'm going to hit 50 and enter, and now it tells me that my slope is 1.4. Okay, so now I know my slope is 1.4. Now the last part says find the equation of the tangent when x equals 50. So to figure out the equation of the tangent, I'm going to hit second PRGM. So second PRGM, which is draw. It says right here in small print, it says draw. Okay, and then I'm going to go down to 5 where it says tangent. So I'm going to go down to 5, hit tangent or hit enter, and then once again I'm going to type 50 and then press enter, and now it draws my tangent line, and it tells me the equation is 1.4x plus 50. So here's how you find the equation of a tangent line using a calculator, finding the slope using a calculator, the derivative, I just did this using the power rule, And there you go. I hope this helps you with the homework.